This is Kristin Beltzer, and I want to welcome you to another segment of Connect with KB. This episode is brought to you by Marketing Resource Group, your full-service strategic communications firm, and the Aerospace Industry Association of Michigan. You can learn more about MRG at mrgmi.com. Trilion Quality Systems offers optical testing and metrology systems, as well as advanced consulting services across North America, with Great Lakes offices in Southfield and near Detroit. Their systems and services provide optical measurements that are a dream tool for engineers in design and manufacturing, especially in the aerospace, automotive, microelectronics, biomechanics, and civil industries. A member of the Aerospace Industry Association of Michigan, my guest today is John Tyson, president of Trilion Quality Systems. Thanks for joining me, John. It's great to have you here.
Well, thank you very much. It's a real pleasure being here.
You bet. I want to talk a little bit about the Trilion Quality Systems story. And you started this how many years ago?
About 22 years ago. We started the company after having already experience in the full field optical measurement world. We started out with laser holography and chirography way back in the beginning. Those are really powerful measurement tools and for scientific measurements, but they weren't terribly useful in the broader applications. And so we started moving into 20 years ago, we started out with our stereophotogrammetry capability, and this technology is just incredibly powerful. We're Industry 4.0, we were doing that 20 years ago, so it was pretty interesting. And the power of the stereophotogrammetry is that we're able to measure true 3D coordinates dynamically in understanding engineering problems in real 3D coordinates. So it's in real world measurements. It just can really simply make measurements. And so we have really been benefited by the fact that camera technology has gone right through the roof, computer technology has gone through the roof, and vision-based systems are used everywhere. So these powerful capabilities have all come together in what we're doing in stereophotogrammetry, in understanding how mechanical systems work. And
how does this benefit the aerospace industry?
So we've been applying this technology for quite a while, and my background has been aerospace composites since the beginning. I worked on the original, when the B-2 bomber program was a black program, and people gave me parts and said, can we find the defects in these structures? And please don't tell anybody that I gave you these parts.
Wow. So, I mean, it really makes me kind of think of how I just watched the documentary on the Challenger and about the O-rings. And
right.
Is that the kind of thing that you would do? I mean, is it breaking down those kind of things to understand how systems go wrong or go right, I guess?
Well, I was working on the space shuttle problems at the time, and our technology really came into the forefront with the Columbia accident, and we were brought in to help validate the computer models to get the space shuttle program flying again. And so we made all the measurements of the foam hitting the carbon-carbon leading edge that we were one of the line items to fix the space shuttle to get it flying again.
Is that right? Well, tell me a little bit about, you've said a lot of terms here already. How does that impact companies? How do they use your services?
So exactly like what we were doing on the space shuttle program, we were validating computer models. So they thought they understood how the space shuttle worked and how the materials responded, and the model showed that there was no damage to the space shuttle, so they brought it back down again. When it crashed, it really shook the entire engineering community because we thought we knew what we were doing. Turns out that the models were old models from the 70s, and they did not predict the right response. And they also had never validated those models. So it really, not only was it Space Shuttle, but all through engineering communities were really affected by that because they were starting to rely on computer models, and here the computer model failed. And so people continually need to validate their computer models to make better products, to produce better products. Boeing guys now use our equipment regularly daily to understand the material response of their structures. And top modelers have told me that our technology is crucial for understanding reality, because their models are just models. They're trying to model the behavior of these structures, but unless they're validated properly, they're still just models.
So have you had any hand in this Boeing 737 MAX and the fact that, it's going to begin to fly again? And I watched that on the news as well, and people are suspect of that.
Sure. Of course, the Boeing 737 MAX problem was a software problem, and it was really how the pilot flies the airplane and the controls the airplane has over the flight. And so it has nothing to do with the materials and the structures. But we've been working on the 787 and 777 structural testing and how they work. And they had a problem with the 787 early on where they bent the wings up and it broke unexpectedly. They brought in our equipment when they fixed that problem, and we were able to, they had used over 10,000 wired sensors to validate this structure, and we came in with 4 cameras, and we had over 200,000 sensors validating the problem that they had. They're now going more and more to using our full field optical methods rather than mechanical sensors. We're as accurate, if not more accurate, than the mechanical sensors, being displacement sensors, strain gauges, accelerometers, and using this technology to holistically understand their structures in a better way.
When you say validate, do you have to go through testing after testing after testing? What does validate mean, and how many times do you have to do it?
Well, of course, that's what engineers do. They need to make sure that their operations are working correctly. And this week, we're actually over in Sterling validating a robot, a mobile drilling robot that's is working in the for fighter plane manufacturing, and we're validating the motions of this robot at a level that the manufacturers and Lockheed had no idea how accurate this robot really was, and we're measuring precisely every motion that this robot goes through to validate its structure.
Are your services in high demand? I would think with the expertise that you have, do you have enough capacity to be able to help everybody?
Well, that's a good question. We have offices in Philadelphia, Detroit, Seattle, LA, and Huntsville, and we are always busy supporting our customers and training them how to use this technology. We're experts in the world at using this kind of technology and help our customers acquire it, implement it, and utilize it correctly. And training is a crucial capability of this. And education is a big part of what we try to do. And many of the universities in the Michigan area are teaching the Aramis technology in a really good way, or digital image correlation.
So where would that be happening? I mean, is that happening right here in Michigan in regards to? Right
here in Lansing, I guess, is Michigan State University.
Wonderful.
And graduate programs are being utilizing this. Sharon Zhao is a big user of our technology for many years. University of Michigan, big user. University of Michigan Dearborn, Herman Reyes, and George Ayoub are great users of the technology. Our Detroit office is actually located on the LTU campus, Lawrence Technical University campus, and they're teaching it in the whole program in undergraduate. And this is really where it's important, because our equipment helps engineers visualize their structures in a really good way. And the next generation engineers are all very visual people and gaming-oriented people. This technology is just ideally suited for the next generation engineers.
You are, my understanding, one of the first members of the Aerospace Industry Association of Michigan, and working with Tony Vernesi and the great team over there. What is it that you do with them in terms of partnering?
So working closely with Tony, he's just been really a fabulous supporter of the technology, and we're trying to get the word out on how this technology can help improve the aerospace manufacturing in Michigan and the world. And that's our goal in the whole world. Of course, how all of this aerospace happened in Michigan in the first place is beautifully told in the story of the Freedom's Forge, which in World War II, how did we go from not having any military to conquering the world in 3 years? Just incomprehensible. And Michigan really was a key piece of that. And how that happened and how powerful the aerospace industry is in Michigan is well told in that story.
Well, and I think it's because we have a tendency, and I've said this before when we've talked about aerospace, we can diversify very easily. And we have that capability that so many of these things may have been born out of the automotive industry as well. How do you see this kind of happening with the aerospace industry changing kind of post-COVID? And what kind of an impact has it had on you?
So our technology and services are needed more than ever, especially, we basically, our equipment, we call it an engineer in a box because one guy can just do the work of a lot of people, and he can just very rapidly understand a problem. And it's just really the next generation of understanding problems quickly and efficiently. The guys down at NASA Marshall have said, testing rocket motors and things. He said we used to put, strain gauges all over our structures and try to get them to survive, and then there would be arguments about what the data means. He said now that we're full field optical, it's intuitively obvious what the results are. And it just helps us move quickly and more efficiently into the future.
Well, and when you talk about the future, how do you see your company? And now that John, you've been into this for a long time, how do you see this in the next 5 to 10 years?
Yeah, so the next 5 to 10 years, optical technologies are going to become, prevalent in all forms of industry, and our technology is just ideally suited for moving this forward because work that would take a week to do, we can do in minutes. And not only that week of work, was it really measuring the right thing? Here where you just holistically understand what's going on with your materials and structures and can quickly define, the path forward. And so getting to market quickly with high quality products is the crucial goal of what we're going to be going through in the near future.
Are you working on new technologies right now?
So we're, especially in the aerospace composites world, we're very involved with in situ monitoring of composites, which are understanding how the part is being built, understanding the material properties, the in situ monitoring, so you make good parts every time. Then in digital manufacturing, we're doing digital assembly, just optically without tools. I mean, you could go into any building and start building structures with our equipment. And then be able to track it through structural test and lifelong structural health monitoring, just really simply and efficiently, like visual inspection. That's a pilot going out and looking at his airplane. But with video cameras, we're now, and the power of our digital twin database allows you to understand everything holistically, precisely, and through the life of the structure. What
have you enjoyed most about this career?
We're just on the cutting edge of technology all the way along since our beginnings of laser holography, doing things that just seemed miraculous at the time, and now just doing it every day. It's just been a wonderful trip. the whole thing.
Do you see this really, really growing in Michigan in regards to the opportunities here in aerospace?
I think it's the next generation of capabilities within the engineering world. And so teaching it, even in high school, through materials, structures, and validating finite element models as like MATLAB, but is now the tool to use in understanding engineering systems and structures.
Do you have an opportunity to get into classrooms at all and talk to students?
Yeah, I teach regularly, so I've just taught a class down at the University of Tennessee in Knoxville. They're a cutting-edge capability of in commodities manufacturing, and work closely with the Oak Ridge National Labs there. And I teach classes around the world.
Do you find that there are a lot of women that are getting into this?
So it gives everybody the power of an entire department, and so it's. Men and women all use it just equally well, and it's just a really powerful tool and a very enabling tool.
What has been the best thing about working with the Aerospace Industry Association of Michigan?
So the Aerospace Industry of Michigan has been just fabulous at introducing us to and introducing the aerospace industry in Michigan to advanced technologies like ours.
Yeah. John, I appreciate you being with me today. Thanks so much.
Thank you very much. It's been a real pleasure.
You bet. Thanks so much for listening to this episode of Connect with KB. I want to thank my guest, John Tyson from Trilion Quality Systems, and in today's episode sponsor, Marketing Resource Group and the Aerospace Industry Association of Michigan. I'd also like to thank my supporting sponsors, White Law, Dowding Industries, Governmental Consultant Services, AF Group, AT&T, and the Loomis Law Firm. You can listen to all of my podcasts at connectwithkb.com. Until we connect again, go live your best life. I'm your host, Kristin Beltzer.